Okay, today's lecture, we will continue on properties of Fourier transform and do some analysis using the properties, doing some Fourier transform using the properties. So we will not keep using the integral formula. Most likely we'll try to use the table and the properties of Fourier transform. And again, all the tables and the properties tables will be provided to you. So you don't need to memorize anything, but you need to know how to use these tools in the right way, in the easiest way for you, shorter time, less effort. Okay, so the time today is Monday. So the readings page 261 until 263. And it is the due date for homework number 13. Then on Wednesday, 4/17, the readings page 261 to 63, which is continuing Fourier transform. So we will try to finish it by Wednesday, but if we cannot, or if we still have more examples, then we finish it by Friday. So if we need to work more in Fourier transform, we will work on it. If we are done, we will go to the body blocks. And it's on Friday, the due date for homework number 14 and homework number 15. And again, homework number 15, no submission required. It's just like for homework number 14, while in 15 still required in the test. So it's the submission due date for homework number 14. So if we finish by Wednesday the Fourier transform, even if we start body blocks in Friday, it will not be included in baseline. So body block will not. The exam 3 will be only Fourier series and Fourier transform. So on Monday, the 22nd, it will be exam, the day of the exam. Then after that, we will have 2 more lectures before the end of the last class day. So on Wednesday 24, we will go to body blocks. Then in 26, Friday, which is the last class day, it will also be about the body blocks. So here's the one the classes ends. Some important tables about Fourier transform. Which is table 5.6 and table 5.7. Those tables are important for your review because most likely this will be provided to you. And these are the tools that you need to use them when you do Fourier transform. Okay? Now let's start the lecture. So I'm going to assume this example. We need to first find the time domain. After that, we will find Fourier transformation. So how to find Fourier transformation for this one? Or before doing Fourier transformation, let's try to find the time domain. Actually, this one, here's the 615. This can be denoted as a trifunction. We already before discussed impulse function, rect function. Now there is a new function that we haven't discussed before. It's called here, this one. This can be denoted by trifunction. So anything like triangular can be trifunction. Okay, so how we can manipulate the trifunction? Basically, trifunction will be t minus center over width. Something very similar to what we discussed for the rects, minus center times the width. So look here at the center. This function is centered at 0, which is the origin. And the other thing, which is the width, is tau minus 2 minus tau minus 2, which will make it tau. As a result, we can say x of t equals to x of t will be tri of t minus center 0 over width tau over 2 minus tau over 2, or in other words, it will be tri of t over tau. Okay? So starting from now, you need to be aware what does tri mean, what does t over tau mean, or how we calculate it. If it is t minus, if for example, tri t minus 1 over tau, this means the tri function will be centered at 1. Then here is, for example, 0, here is tau, then here's, for example, centered at 1. So we can say that, for example, tau is 2, as an example. Okay, so you need to keep this in mind and how to draw the tau. So we know all of the properties of if it is shifted, left shifted right, tau minus 2 or tau plus 2, etc. So we are already expert at it. But here just need to keep in mind the tri function, how we can do the tri function. Okay? So the overall is, the question is how to find the Fourier transform of tri function, tri with t. How to find the Fourier transform? That's a concern. How we can find it? We can try to plug that function into a time domain. It is ramp function and another ramp function. Okay, how we can do the ramp function? After converting this to ramp, you can find, we know how to do the Fourier transform of the step. Then do the integration of the step will be ramp. Is this correct? We can say the tri function, something looks like, here is ramp, here is ramp. And we know the ramp is actually the integral of the step. So if we find a way, and we know the step, how to find the step for your transform of the step, we already know how to do this. So our target is, how about try to find the Fourier transform of the step first, then use the integral property to find the Fourier transform of the ramp. That's something that we can think about. So here I'm trying to use Fourier transform analysis in proving this, or the properties of Fourier transform. So basically, my idea now, similar to what we did in ramp and step, but I'm gonna, in order to use the integration property, use the integration property. I will find the derivative first. The derivative first. So basically, here is x of t. So such that here is 0, here is negative tau over 2, here is tau over 2, here is 1. This is x of t. Now we need to find the derivative. How to find the derivative? This is a linear function. So linear function, let's put the brackets here, tau over 2. Tau over 2. A linear function, the derivative of the linear function is the slope, right? If we have a function like y equal ax plus b, then dy by dx equal to a, which is the slope. So what's the slope of we have in the left-hand side, right-hand side? So what's in the left? The slope. Slope here equals to 1 minus 0 over 0 negative tau over 2. As a result, the slope will be 2 over tau. The other one, the slope will be the opposite, negative 2 over tau. So the first one will be positive with a slope 2 over tau. The next one will be negative with negative 2. Now this function, since it's the derivative, I'm going to call it as y of t, such that this y of t equals to dx of t y of t. So my idea is, let's try to find, after finding the derivative, find Fourier transform of y of t first, then after that, in order to find for x of t, which is the original function, I'm going to do the integral. So what we will do is, we will do Fourier transform of y of t, then Fourier transform of x of t will be Fourier transform of integral y of t dt, something like that. And the integral means we can apply the property which is 1 over j, omega, etc. So we can do the property. So let's try to find Fourier transform of y of t. In order to do it, we need to plot this or to rewrite this as a time domain expression. And of course it's going to be as u of t function, as a step function. So y of t can be manipulated here, again tau over t, then from negative tau over t until 0, then the second step with negative tau over t from 0 until tau over t. So basically, we can say y of t as a function, and we know how to deal with this when we discuss the first exam material during our first month, how to do the step function. So it will be 2 over tau, then it's like impulse, it's like, like a big function, so u of t plus tau over 2, here is the on time, minus u of t, here is the off time. This is on, this is off. Then the next pulse, it will be negative 2 over tau. Why? Because it is the second pulse, we are here, negative. So it will be negative tau 2 over tau, the on time u of t, minus off tau u of t minus tau over t. So this is on time, this is off time. Then let's try to simplify it more. Let's try to simplify the time domain function, because we have similarity. We have u of t here, we have u of t here. So let's try to simplify it. Basically, after doing this multiplication, u of t 2 over tau u of t minus plus tau over 2 minus 2 over tau u of t minus 2 over tau u of t minus will be plus 2 over tau u of t minus 2 over 2 tau over 2. Then we can group these two together. So the answer will be 2 over tau u of t plus tau over 2 minus 4 over tau u of t plus 2 over tau u of t minus tau over 2. Okay? That's y of t. Now, after I simplified it, this is the simplest way in time domain, I can do it as Fourier transform. Recall, Fourier transform of u of t is actually 1 over j omega plus pi delta of omega. That's the first thing. And the other thing, recall whenever you have x of t minus t0, this means x of omega e power negative j omega zeros, something like that. So we have, when we do the Fourier transform, we need to apply shifts and apply for u. So what does this mean? This means when we do a Fourier transform of u of t minus t0, this will be 1 over j omega plus pi delta of omega, all of it times e power negative j omega negative. Now, after here, I try to put this in my mind so I can be capable of how to do the Fourier transform. So let's do Fourier transform, which is y of omega, which is Fourier transform of y of t. This is going to be the first one, constant 2 over tau, Fourier transform of u of t plus tau over 2, then minus 4 over tau, Fourier transform of u of t, then plus 2 over tau, Fourier transform of u of t minus tau over 2. Now I can substitute one by one. So the first term, tau over 2, Fourier transform of the first term, u of t plus tau over 2. This is going to be as 1 over j omega plus pi delta of omega, all of it times e power j omega tau over 2. That's the first term. Then the second term, minus 4 over tau. What's the Fourier transform of u of t? 1 over j omega plus pi delta. So the difference between this one and the other one is just the exponential function, because according to the properties, there will be an exponential when we have the shift. Then plus the last term, 2 over tau. So here it will be 1 over j omega plus pi delta of omega, then e power negative j omega tau. Okay? Does this make sense? Now let's try to simplify it more. We can take the terms of 1j omega alone and the other terms alone with pi delta alone. So let's try to group 1 over j omega alone. This will be 2 over tau e power j omega tau over 2 minus 4 over tau plus 2 over tau e power negative j omega tau over 2. So we'll try to group 1 over j omega alone. Then the other one, try to group pi delta omega alone. Pi delta omega, this will be as 2 over tau e power j omega tau over 2 minus 4 over tau plus 2 over tau e power negative j omega tau over 2. Okay. Now we need to keep in mind we have a delta times this function. What does this mean? You call sampling property, which is the property of delta function. We used to say before, when we have delta of t times f of t, this equals to be delta of t times f of 0. Do you remember this? Delta function? Okay. Now we have in time frequency domain. That was in time domain. In frequency domain, it will be something similar, and we will say a delta of omega times f of omega equals to delta of omega times f of 0. In other words, when we do the delta, we need to substitute omega equals 0 in this expression. So let's try to substitute. Look at this expression. 2 over tau e power j 0 tau over 2 minus 4 over tau plus 2 over tau e power negative j 0 tau over 2. E power j 0 will be 1, e power 0 will be 1. So it will be 2 over tau minus 4 over tau plus 2 over tau. Take tau as a common factor. This is to be 0, because they will cancel each other. Then, this means I can redraw it. Y of omega equals to 1 over j omega, 2 over tau, equal j omega, tau over 2 minus 4 over tau, plus 2 over tau, equal negative j omega, tau over 2, plus pi delta of omega times 0. That's what we got. We got 0. And anything times 0, this will be 0, because it's 0. As a result, we can take 2 over tau as a factor, 1 over j omega, 2 over tau then it will be e power j omega tau over 2 minus 2 plus e power negative j omega tau over 2. Okay? Now, can we simplify it more? We need to simplify it in the simplest way. Remember, whenever we see e power negative j, this means there must be sine or cosine. Now, let's try to find a way. Is there any way to make it sine or cosine? Let's think about it. So it will be here 2 over j omega tau, then e power j omega tau over 2, plus e power negative j omega tau over 2, minus 2. I just changed the order. Then we have this function, e power j omega plus e power negative j omega. Is this similar to sine or cosine? Sine or cosine? Equal sine theta e power j theta minus e power negative j theta over 2. While cosine e power j theta plus e power negative j theta divided by 2. So there is addition. This is similar to what? Cosine. Then let's try to think about e power j omega plus e power negative j omega. This is not exactly cosine. There are some terms that we need to do. So basically, we can say e power j omega tau over 2 plus e power negative j omega tau over 2 equal 2 times cosine omega tau over 2. Okay? Just start to multiply. Okay? Does this make sense? This is equal to 2. As a result, we can substitute it as 2 over j omega tau. Then here, there will be, which is we calculate equal 2 cosine omega tau over 2. Then minus 2. Understood? Let's try to simplify it more and more. So let's take 2 as a factor. This yields to be 4 over j omega tau, then cosine omega tau over 2 minus 1. Now, can we simplify this? Okay, now it's like a math course more than sequence. So we need to simplify it more. How can we simplify it? Recall the trigonometric identity. The trigonometric identity says that cosine 2 theta equals to cosine squared theta minus sine squared theta. There's a trigonometric identity. Or it can be 2 cosine squared theta minus 1, or it can be 1 minus 2 sine squared theta. Okay? So it can be any of these three. I'm going to focus more on cosine 2 theta equals 1 minus 2 sine theta. Then I would say how to make 1 minus cosine. So what I'm going to do is the first thing.
Is that minus 2 sine?
Yes, squared. Correct, minus sine squared. Thank you. I'm going to substitute 2 theta equal x, then x will be theta over 2. So what will happen? I will substitute it as cosine x equal 1 minus 2 sine square of x over 2. Okay? Just like I'm trying to play with math. Then I would say 1 minus cosine, try to move the terms. 1 minus cosine x will be 2 sine square x over 2. Okay, does this make sense? Now, when we use this result, we will try to apply it to what we see in that bracket. How we can use this result to do cosine omega tau over 2 minus 1? How can we play with this to apply the formula? So cosine omega 2, omega t tau over 2, it can be basically negative. I'm going to put a negative over here. 1 minus cosine omega tau over 2. Right? Then assume x equal omega tau over 2. Then we can apply this. Substitute x as omega tau. So by applying this formula, it will be negative. Negative 2 sine square of x here, which is omega tau, over 2 will be over 4 minus 1. This is this. Then I can substitute this on the original expression. So this is y of omega equals to 4 over j omega tau. Now I can substitute what we get here, 2 negative 2 sine square of omega tau over 4. Then I can put negative 2 outside of the brackets, which will make it negative 8 over j omega tau sine square omega tau over 4. Okay? This is y of omega, then this is the final answer of y of omega. But I'm not done yet because this is y. I need to calculate for x. How can I calculate for x? We call x or y of t equals dx by dt. Therefore, in order to calculate x of t will be the integral from negative infinity to t, y of tau dt. Or in other words, using the integration property, x of omega equals y of omega over j omega plus pi y of 0 delta of omega. That's from the table integration property. Okay, how to find y of 0 before applying the integration property? How to find y of 0? So again, we have y of omega given as negative 8 over j omega tau sine square omega tau over. Now we need to calculate y of 0 when we calculate omega 0, which will make it negative 8 over j omega 0 sine square of 0, which will make it 0 over 0. 0 over 0, this is something that's we don't want, then we can apply, we will do the derivative, right? Find the derivative for each thing. So let's find the derivative for numerator and denominator. So it will be negative 8 with respect to omega 2 times tau over 4 times the derivative of sine is 2 times cosine. This is 2 times sine cosine. Sine omega tau over 2 cosine omega tau over 2 divided by divided by g of 0. It's not like this. When we do the rule. That substitutes, I would say I can add a limit. This is y of 0. Then, now I need to substitute over here over j omega over j tau. Then, let's substitute omega equal to 0. This yields to be negative 8 tau over 4 times 2 sine of 0 cosine of 0. Cosine of 0, 1, but sine of 0, 0. We'll make it this term equal to 0. Then the last term, j tau, this is constant. So this yields to be 0 over j tau. This makes it 0. So as a result, we got y of 0 equal to 0. Then, let's go back substituting x of omega. X of omega equal y of omega divided by j of omega plus pi y of 0 delta of omega. And y of 0 is 0. This term can be equal to 0. Then the remaining thing, which is x of omega equals y of omega over j of omega. Then substitute them. It's going to be as negative 8 over j omega tau sine square of omega tau over 4 all of it divided by j omega. Then, more math. Negative 8 over j omega all of this square, or I would say j squared omega squared. J squared omega squared tau, sine square of omega tau over 4. Okay, recall j is the square root of negative 1. Therefore, j squared will be negative 1. Then this one and this one will cancel each other. This will be negative 1 will be constant. More math. 8 over omega squared tau, sine square of omega tau over 4. Okay. Now we need to do more, which is convert this to sine. Who likes math? Actually, I used to be a big fan. After this example, no longer. Now, we need to convert sine theta over theta to be sine. So we have inside here omega tau over 4. So what I will do, which is try to make it omega tau over 4, omega tau over 4. To make it as a sine, and all of it will be squared because it will be sine squared. So as a result, this will make it 8 times omega tau times omega tau over 4 omega squared sine square or sine omega tau over 4 divided by omega tau over 4 all of the square. This means this term can be converted to sine. Then the square and 4 square, so we can do some simplification. Tau and omega and cancel each other. But here's this is omega squared. Omega squared. So omega squared and omega cancel each other. Tau cancel the square. So this yields to be, after doing the simplification, to be tau over 2 sine square of omega tau. So this is fixed. Then finally here. Okay. This result can be used as a general result. So we can use it only also, put it in our tables, in our notes formula sheets. So we can say whenever we see any trigonometric function, we can convert it to Laplace using Fourier transform. So we can say this is the summary. 1 tau over 2 is 0, 8 tau over 2. Here is x of t equals tri of t over tau. Equals t. Then we can say, to convert Laplace transformation tri tau over tau, t over tau, we can put it in our table. This will be tau over t sine square of omega tau over 4. Okay? So we can take this result starting from now as is, unless you need to prove it. If you see any question on the homework or whatever, prove this. Then you need to prove it using what we do. Now there is also a nice feature here, tau over 2. This is actually, look at the area of this triangle. So here area equals 1/2 times the base times the height. 1/4 times tau times the height, which will make it tau over 2. So as a result, this will be as area times sine square omega tau over 2. The area. And we used to say x of 0 is the same as the area. So we can say another thing, which is this will be x of 0 sine square omega tau over 2. Or the area. So whatever. So we can use two representations, whatever more convenient for you. Any question? Okay, let me just have a few seconds break, then we will go to the next example. Starting from now, we will use this feature. We will use our methods. Now, We know the Fourier transform of step function, impulse function, sine function, rect function, now the trigonometric function. So we have so far 5. We can use this in finding Fourier transform of any signals that we have. I mean, not any signal, and some simple signals. But sometimes these signals might not be a rect function, might not be a tri-function. I need to find a combination such that I can make it as rect or triangle. How? Let's see this example. Find Fourier transform of this example. Here is x of t, here is t, then 0, 2, 0, 3. Okay, how can I find Fourier transform? You can find it using the original way, basically try to convert this into time domain or find the time equation. After that, you need to convert this to rect function by doing the derivative, the same example that we did before. Then after find the time domain rect function, convert this to step function, define Fourier transform for each one. This will be using the long way. However, we can use what we learned from the tri-function and the rect function. How? Okay, let me just put so I can say this function can be split into two things. It can be split as rect function, -2, so 2 with negative 2, subtract minus, and tri-function, like this one. So I can say this is A of t, this is B of t. Okay? Does this make sense? How we figure it out? We basically try to subtract A minus B, this yields to x. X of t equals to A of t minus B of t. Okay? Here. Good. Now let's try to put the function of A of t. A of t is actually a rect. So here the width equal to 4, 2 1, and center at what? 0. So basically we can say tau. Then the same thing here. Width equal to 4, center at 0. So I can say, substitute A of t as it will be the amplitude 2 times rate of t minus 0 over 2 minus 2 minus 2 the triangle of t minus 0 over 2 minus 2. As a result, the time domain x of t will be 2 rate of t over 4 minus 2 tri of t over 4. Okay, do you know how to find the Fourier transform of x? Yes. Try? Yes, we do. So basically, it will be as x of t, or we need to find Fourier transform. X of omega, which is the Fourier transform of x of t, will be 2, the Fourier transform of x, t over 4, minus 2 Fourier transform of the triangle t over 4. Then substitute them. It is 2, the Fourier transform of the rect is actually tau sine sinc of omega tau over 2. Then minus 2, the Fourier transform of the tri-function is tau over 2 sine sinc square of omega tau over 4. You are not required to memorize this. You should have them in your formula sheets. Formula sheets in the test will be provided to you. In the homeworks, you have an access to it. Okay? Then, basically, substitute tau equal 4 because that's what we have. So let's substitute tau equal 4. This yields to be 2 times, this one will be 4 sine of omega 4 over 2 minus 2 tau here, which is 4 over 2 sine square of omega times 4 over 2. Then let's simplify it more. We'll get it 2 times a4 will be 8 sine of omega 4 over 2, which is 2 omega. Sine of 2 omega minus here 4 over 2, 2 times 2, 4. Sine square of omega 4 over 4 will cancel each other, which will be 4. And that's it. This is x of omega. This is the final answer in quantum mechanics. So we can say that we don't need to go back to the original method like what we did before, but here, that's how we can. Any question? Let me do one more example similar to this, but quick. Basically here, I just want you to learn the tool and how to do, to split the function to do different things. So I'm going to assume we have t here, here is x of t, then negative 1, 0, 1, 2, negative 2. So it will be this. So we're going to do this one. So we need to find Fourier transform for this. To find Fourier transform, we can split this function as two trifunctions. How? Here is it. Basically, the first tri will be the big one, from 2 until negative 2. So I can say this is a of t. Then subtract it. And another tri between 1 and negative 1, 2. And this is what we call u. So all of them have a bit more. No, this one actually. Try to subtract a of t and b of t, this will be this. So as a result, I'm going to do it quick. X of t equals a of t minus b of t, which is going to be 2 tri of t over 4. We should be now experts in how to read that with the tri. T over 4, because it's similar at 0, 2 minus minus 2 will make it 4. The width is 4, minus tri of center at 0, t, and the width is 2. 1 minus 1 will make it 2. So here, tau equal 2, here, tau equal 4. So here, everyone has its own time. Then how to find x of omega? X of omega equals the Fourier transform of x of t, which will make it 2, the Fourier transform of tri of t over 4, minus Fourier transform of tri t over 2. Keep in mind, here's tau equal 4, here's tau equal 2. So in the previous example, they were the same tau. Now each one is its own tau. So let's substitute them. It will be as 2, and what we know about the sink, which is I think tau, that will equal the sink, which is tau sink, tau over 2 sink square, tau over 2 sink square of omega tau divided by 4. Omega tau divided by 4. So the first one substitutes 1 tau equal 4 minus the other one tau over 2 sink square omega tau over 4. Here, keep in mind, substitutes 1 tau equal 2. So So each one has its own tau. Then this yields to be this tau equal 4 over 2 will be 2. This yields to be 4 sinc square of omega tau, which will make omega times 4 over 4, will make it omega, minus 2 over tau, and here 2 over tau, 2 over 2 will make it 1, and sinc square of omega, 2 over 4 will make it omega over 2. And this is x of omega, that's of omega. Okay? Any question? Now I know that the math can be complicated, but the idea on the last two examples, I want you to use the results that we have, use the tools to do more challenging problems, like this example and the previous one. Basically, the key, you need to know how to convert this into A and B. Other than that, it's just as straightforward. Any questions? Okay, so these are tables. Table 5.6, different than the signal portfolio how to do different signals. We see the big function, the sine function, u of t, delta of t, how to do the shifts. Then this is another table using the properties that we learned. And you can see here I added a trie. It's already been added the sheets. And here's the sine and cosine, the trigonometric. Here just recall also previously, so this is two formula sheets are important, and this will be this page or another page because they will be provided for you in the test. Let's do the property number 8, because we still have 3 minutes.
Could you post the formula sheet for on the campus?
Yeah, the formula sheet will be posted, I think, maybe by Wednesday. Anyway, these notes, you can find these 2 sheets, because this notes will be posted today. So you can see these 2 in the videos. We still have 3 minutes. Property number 8. Modulation. So basically, when we have x of t times cosine omega times t equals x of t times 1/2 e power j omega naught t plus e power negative j omega naught t. So when we have sine or cosine, we can convert this into what? The Euler formula. So why I need to do this? So I don't want to make Fourier transform complicated. So basically, it can be as x of t divided by 2 e power j omega naught t plus x of t divided by 2 e power negative j omega naught t. And this is similar to frequency shift property. So as a result, here assuming this is y of t, Fourier transform of y of t, in other words, this is y of omega, will be 1/2 Fourier transform of x of t e power j omega naught t minus or plus 1/2 Fourier transform of x of t e power negative j omega naught t. Then, when we do the Fourier transform, it will be as 1/2 x of omega plus omega naught plus 1/2 x of omega minus omega naught. That's what I want. So using the power. So as a result, we can use this conclusion. When we have x of t cosine omega naught t, or when we have x of t sine omega naught t, the Fourier transform will be 1/2 x of omega plus omega naught plus x of omega minus omega naught. Then, for the other one, will be 1/2j x of omega minus omega naught minus x of omega plus omega naught. So these two results can be found here. I just calculated the cosine. You can calculate the sine using this problem. Okay, does this make sense? Okay, let's stop here. See you on